maybe we are more focused into areas where we are not giving much attention in our professional career. There's one main thing what I would actually wanted to say, or maybe wanted to bring topics regarding to quality and quality applications. This is, so I thought maybe because of the previous ones, apart from the previous one, there are so many topics. So the next one I choose is Six Sigma and Lean Six Sigma. It's an overview of, maybe I don't know how many of you have heard about this Six Sigma tool. And nowadays it is actually practiced in many organizations, mostly into the manufacturing sector, but it is actually also used in the construction sector. And you can use it anywhere because it is all depending upon elimination of errors and then elimination of waste or reducing waste. So let us see the journey of success, how this Six Sigma is actually come into picture since when. We can see that people started developing conceptual procedures starting from 1920 and all, because the year is very significant here because this First World War started, then the Industrial Revolution actually picked up. A lot of machineries wanted to manufacture for the use of war. That is how things wanted to do it in a proper way. So that is how the engineering mainly developed because of wars. And then it comes to statistical process control by Mr. Deming. Actually, he is the father of all this, most of the tools which is actually introduced in quality system. Because statistical process control is a standard deviation procedure, which is actually finding out your variations, how much variation you can go, so you can control it. And then comes to 60s and 80s, total quality management by Ishikawa and Crosby. That is also, he developed so many tools like Ishikawa diagram, the cause and effect diagram, things like that. Then it comes to Six Sigma by the person is actually Deming and Walter Stewart. That is another person. What his name is Walter and this thing. And then it comes to 2000 and beyond. It is Lean, because Six Sigma was there, and then they added Lean. That is Kichiro Toyoda, 1930, after World War II, because they started, because all this philosophy is actually developed in US and all, but it is implemented mostly in Japan. That is how it is actually the journey of excellence. We can say that these are the people who contributed a lot or put their brain into developing tools which we can achieve maximum value of the product, what your services, what we are doing. So if you do a little bit of what is Six Sigma, what is actually basically it is a vision and philosophical commitment to our consumers to offer the highest quality, lowest cost products. Because whoever is actually managing an organization, because they will have a vision. To achieve this vision, you have to brainstorm it and get some sort of a philosophy so that the cost of the product can be kept less with a higher quality. And a metric that demonstrates quality levels at 99.9997%. This is called Six Sigma, because 3.5 defects in a million pieces, million opportunities. That is what limited to, because we were having up to 3 Sigma, that is 2,500 something defects in a million opportunities. But that is reduced to 6 Sigma, going almost near to zero. Like defects cannot be, you cannot afford to have defects in your manufacturing or your projects or anything, because you will lose a lot of time, money, effort, and things like. To achieve that, what are the things? These are all quality tools using standard deviation and other things. And a benchmark of your product and processes capability, because once you achieve a Six Sigma, because you always reach to a level, you can say this is our benchmark, this is the basis what we work. So we can establish some kind of a benchmark. But we have seen in one of our previous continuous improvement, the benchmark is a 7. We still go on doing it, keep on changing, because we always have a competitor which will go above us, or maybe we compete with us and you cannot stop it. So it is a continuous effort always been put. A practical application of statistical tools and methods to help us measure, analyze, improve, and control our process. These are the 4 things which is normally when you do the process. As a DMAIC, he actually plan. We have seen that before, So along with that, he has actually come up with this tool as well. So what are the objectives? When we do Six Sigma, because Six Sigma can be defined as a methodology that uses organizational tools with an objective to improve the capability of their business process. Because it is, like I said, it has brainstormed and then coming out with a process improvement, a methodology, so that you can have a improvement in your process and your services. So the ultimate objective is of Six Sigma is the following, like needed less human effort to design product and services, because you don't waste your time or how much effort is required. So accordingly, you can streamline the resources. Accordingly, you don't need to put so much of people for a little work. We can study it and see that how much human effort is required, or maybe resources are required. Needed less inventory and then every process step, because in a process starting, if it's a construction, what are the things you require, how much you require, when you require, how long, all this process you can find out using other tools, which we have seen before with so many things. So these are the one advantages or objectives. Increase performance. Sorry, the people will improve their performance by understanding a kind of methodology which is already approved or maybe brainstormed and introduced. So a good quality performance can be achieved. Decrease process variation. This is we have seen in 7 QC tools. Control chart, process variation. We have one of the tool was control chart, which is actually showing the process variations, which is a certain line, and then we cannot go beyond certain lower end decided by the management or the system, or the client will say, I don't accept a product or a service which is more than this much. So you can control that process variation. Then reduce defects. That is the main objective. 3.5, 3.4 defects in a million. So you do all the standard deviation. Then profit enhancement. All this together, what is actually you are going to achieve is a profit enhancement in doing all the tools applied. The methodology is applied in such a way that you achieve a good product or a services or a construction, whatever it is. Boosting employee morale and safety. Employees are actually being boosted their morale, and they will be happy to participate in basic brainstorming as well as safety situations, because you do things organized, it is more safer. Improving quality of products or of services. Eventually, you achieve a good quality product and services to the client. So the goals of Six Sigma: improve performance service, that is reduce defect, stabilize processes, customer satisfaction, because you work everything what you do for the satisfaction of the customer, your client, then only you get paid, because that is the delighted customer. How do you do it? Achieving all the tools, or maybe your total resources has to put your effort in such a way, organized manner, quality manner, speed or efficient manner, so you can achieve an improved performance and service. Similarly, in the same time, it will reduce cost. Improve efficiency will be increased, and eliminate waste, that we will see later. What are the different kind of waste in an operation or a service? Reduce cost of poor quality. So because cost of poor quality is something which is you pay for. You may rectify it, or maybe your client will not accept it. You have to rework. This is an additional cost you are going to put it on your product or maybe your services. Then the necessity of Six Sigma, why we use it actually, because if you see that there are three basic elements, you can see that: product, process, and people, because this is more or less associated with the outcome of what you're doing. That is a product, which is big quality variations, occurrence of same defects. So you have to see that the quality variations has to be limited so that the defects are minimized. So the product will come out as what the client wants for the functionality which is actually designed for. And the second thing is the process. So how, when you do this, there is a process which will start the input as well as you get an output. During that period, this is called the process. The process time, what are the things you need to take care of to achieve a quality? So that is the process. And then provision, not enough provision of unified information, because information and communication is one of the most important thing for the people to achieve the certain level of quality, because knowledge sharing is always required to have the understanding better for your work as well as your objectives. And people, high quality cost, and then the skills of the people are very important. Not enough provision of unified information. There is no information available. People will be scattered. Each one will be doing their own ways, and then it will not be good to achieve the objective what you want. So this thing will be taking another level, which is direction of problem solving. So that is scientific and statistical approaches are necessary when your product, that is what Six Sigma is. Elimination of waste and element, that is Lean Six Sigma. And continuous learning. These two are a process which will do a continuous learning and improvement. A continuous learning is very important for enhancing your knowledge about what work or task you are doing. So that is what we were discussing. The fundamentals needs to be very clear to do a task. Decision making is based on your strength of knowledge. Your knowledge, if you are not very strong in your fundamentals and knowledge, you can't take a decision faster or maybe a correct decision. So that is what, and your exposure should be there. How others are doing their work, the similar thing you can learn. Then you come to choosing the kind of thing, because Six Sigma, there are so many methods are there. So something similar to this we have seen earlier in the continuous improvement. That is also, it is when it is time versus performance. You can see that continuous improvement DMAIC. DMAIC is actually a process which is we are going to see now, which we do it, and it is a continuous improvement. A traditional movement, this 4-8D, that is also another tool. Actually, we are not covering that here. It is also another tool which is used for in manufacturing industry. So you can see that the graph is actually, that is a dotted line which is limiting the defects or improvement, which is going straight. And there is another one, discontinuous improvement, because you break it, that we have seen rapid improvement, in the previous one. How it is actually, it is not a straight line. So based on this, you can select whichever tool is required to be adopted for your process. Then the philosophy, process, and statistics. What is actually the philosophy of this is anything less than ideal is an opportunity for improvement. Because if it is not achieved, the level of quality what we require, and there is a room for improvement. There is always a room for improvement that we have seen in one of the previous presentations. Defects cost money. Of course, any defects will cost your value, your cost for defects, for internal or external, because the client will complain, or maybe internally you have produced the defective one, you need rectification or rework and things. That is all costing money. Money means all the resources, material, money, and manpower. It's all money, resources. It's a very expensive. The process is define, measure, analyze, improve, and control. That we are good. This is actually the DMAIC process, which we are going to see now. Statistics, Six Sigma process will produce less than 3.4 defects per million opportunities. That is actually all this together, philosophy plus process plus statistics is Six Sigma. Because all these things together, it will have that. So Six Sigma is define. Define means what is important. You have to define what you need to do. Measure how we are doing. Because whatever work we cannot measure it, we cannot manage it. That is a saying also there always. Then analyze what's wrong with that. When you measure it, you will see some kind of a question is raised by asking why, how we are doing, and then analyze it and something wrong, and then we try to identify what is actually wrong. Then only we can improve by fixing what is wrong. We can find the solution for what kind of solution is required to improve or to bring back to the normal quality level of that product or a service. Then control to guarantee performance, and then you like your benchmark or something like you control it to reach or maybe establish certain level by controlling it. But if you don't control it, again it can go back to a bad quality level. So you will not allow it. You're always in the process of continuous improvement. And this is implementation of Six Sigma, what we have seen before, plan, do, check, act cycle. This is a DMAIC wheel, which we have seen in the previous presentations. Also, the improve, control, define, measure, analysis, and improve. That is what we were just talking about. Both are actually derived by DMAIC. He is actually a quality guru, we call. So he is actually the one who developed this. So actually, when you talk about these 5 processes, were define and then select a project and define project objectives, and then form a team, map the process, because we have gone through all these tools in 7. Most of them we have covered in 7 QC tools. So once you define and select a project and define your objectives, and then you, as we decide, as we seen just before, because how it is done. Then the second stage is measure, define measures, evaluate a measurement system, determine process stability, determine process capability, graph, actually histograms we have seen, we learned before. These are the tools which is used to do, analyze this level of process. And then analyze, this is actually, we have a cause and effect diagram. You must be remembering this one as a Ishikawa diagram, which is used to finding root cause, that we put it, and then the effect is actually being found. We have discussed and we have gone through this. And then the other one is scatter plot. We have seen that mapping all the readings, and then we are finding what is actually, then you draw a histogram and then trying to find out what is actually the most critical ones. Then improve. That is also the scatter plot, because this we have seen, if you have a straight line and how the same activity which you do in different times, how it is in x and y variables, how it is actually varying between on the basis of x and y. So you are supposed to get some sort of a straight line. If it is too scattered, you are something wrong. Your process is not identical or not really sustainable kind of process what you're doing. Then optimize it. You have to always focus on the core thing. And then set tolerance for X and verify improvement. Study by Six Sigma, the bell mouth, that we'll see later. Then control critical error, that is actually the scatter plot. Control chart, because these are the control charts, because you see your variations, and then see that it is actually within the limits, lower limit and higher limit. You can study it. If it goes beyond that, you can see what is wrong with this particular operations or maybe the process. You can study it. And then monitoring is actually the process, and validate a control plan. So you have to do a validation of the control plan because it is effective or maybe some sort of a standard, and then close the project. That is how it will go. So these are the tools which we have seen before is applied in sort of a process of this kind of thing. You can apply it in other places in a manufacturing system also. This is general. We will come to because I am focusing too much on the construction area, not the manufacturing area now. So the first one, this is based on the construction part, the define, which we have seen what was it. Considering this requirement, the main goal of implementing Six Sigma to manage resources like material, time, capital, and manpower. Because if you want to do a job, what are the things you basically require? You need a design, you need a material, you need a time, and you need a money, resources, or maybe investment, and then you need manpower. So these are the elements which you have, the variables which you can control it so that you achieve what is actually the best you can do. Then efficiently and effectively in order to reduce the defects and cost of construction project. Because if you manage it well, then you can reduce the defects, means the mistakes and the rework and things like that, you can reduce it. And eventually that helps to reduce the construction cost, because you consume more resources, it's more money and time, and you won't be able to finish it on time. And then construction, we already know that everything that does not meet the requirement is come under the term defect. Actually, what is a defect? Defect means something which is not coming as per the specification or as per the client's requirement or as per the scope of work. All the thing in material, construction, and all this thing that can be classified as a defect. So we try to eliminate this defect by defining it, because the first process, then not that the delivery of the project is defined as a significant defect, because once you do a construction, because that is one of the main or one of the example is the Palarivatam bridge, because they handed over a defective item. The result was defective, or maybe the product was defective. You cannot hand over a defective item or product or service because it's cost money. This is what actually defining it. Then order to identify the defects in a construction project. And you have to, how you do it, because there will be, because nobody can do a very perfect thing right from, because there will always be a check and balance. That is the reason you introduce specifications for materials, construction philosophy, and all those activities, what you are taking care, the method statement, how you do it, everything is actually studied well or put together to avoid defects, so that you achieve that. And still you cannot maybe achieve 100%, but maximum possible, so that it will not be a problem for the client or maybe the product what you are doing. A complete structure can be studied and tested regarding different perspective. You know, the testing and all is normally for a manufacturing thing, but still you do testing of concrete, steel, and all the materials what you are using for a construction can be tested. Of course, we will provide you a test certificate, but at the same time, if you have any kind of doubt and there is a normal, the codes and standards specify certain percentage of material needs to be tested to validate or verify what these people are saying is right. So measure. The third one is measure. Second stage of DMAIC is for having a plan for data collection, preparing a sufficient data sample, and preliminary analysis. Because whatever we do, unless and until we don't have a organized way or maybe a plan is prepared, how we do collect all this data, there should be checklists. And how many items, what all things you will check, what is yes or no acceptable or maybe rejected, all these things based on code standards, good engineering practices. So you prepare a kind of data or maybe a kind of what you call data sheets or maybe checklist or maybe inspections sheet, so that you enter all these observations in that and you can analyze what is wrong and what is not, what is good or bad. In this stage, Six Sigma team analyzes current performance through valid data in order to understand improvement opportunity. That is what it is saying. In Six Sigma, what people collect this data and then sit all the team members of the construction or maybe the supplier, with all these other associated companies are also involved in this, like your material supplier, your subcontractors, your own team, what do you expect, and see that what is the data collected is not in line with your specifications, or maybe this is not what the client wants it, or this is not what the client is paying for. So you can take a decision, or maybe you can develop a kind of what do you call solution for these problems if you find in analyzing the data. So the following are the basic steps for measure. Identify measurement and variations, type, sources, causes, and detailed impact of variation on process will be defined by the establishment of measurement. Because like I said, because what are the nature of the defects, or maybe what, if any defect you have identified, how much this is going to give an impact on the project. This defect may be very severe. You can map it also and see that whether it is severe, moderate, or critical, kind of classification also you can do it. Very minor defects, maybe you can absorb it within the limit, but various higher defects you cannot accept. So the measurement system phase, you will do this. Then comes to determine data types. Six Sigma team should define data types that will be collected. The main focus is to decide what kind of data and knowledge required for process improvement. See, like I said, because whether it is moderate, minimum type, or moderate or critical, which one needs to pay attention to improve that particular type of defect. So this is, so all one way or other, in construction site, people do it, but not in an organized manner or documented manner. So that if documentation is one of the most important thing in quality systems, which people don't pay attention or maybe give importance to document what you have seen, what you have observed, what is actually the result or the data is alerting you for taking any decision for improvement, because that is very important, because doing all this only you will know which area you need to put additional resources to process the improvement. Then analyze. In this phase, the main task is to identify when, where, and defects occur in the construction project, and then solve by finding root cause. Because you always, most of the people working in site, a project manager or a construction manager, they always anticipate some sort of a problem, which is normal in any kind of site. So they are experienced in that. So, but if you want to do a detailed understanding of the defect, you have to do a root cause analysis, like Chicago diagram. What are the elements which are constituted to reach to this kind of defects, so that one by one, maybe various departments are involved, various people are involved. You have to come together and get the thing. That is why the root cause analysis. You don't just do a temporary solution, but you have to find the root cause of the problem. Otherwise, it will keep appearing again and again. So that you need to avoid. That will be a problem for if you are giving a warranty or anything for your project, and then it will start showing up again and again, and it will be a problem. Rectification will be very expensive. Maintenance, that will be on your head. So then, in order to run an appropriate investigation, analysis, root cause problem, it is advantageous to study an overall project in 3 different sections discussed next. Okay, that is pre-construction activities. When you want to analyze it, pre-construction activities and processes, and construction workflow and involved processes and activities, quality of material, level of equipment, and competency of team members. Because this is very important, quality of material. How do you make sure that what material you got is the right one according to specification? You have a test report, authenticated test report by the manufacturer. Then the level of equipment, because the construction equipments what you are using is right or maybe good enough, or there shouldn't be any breakdown. And competency of team members. Above all, the people, those who are actually at site or maybe giving instructions or carrying out the construction work, and advising people at the lower level what to do and how to do. So their competency, how much experience they have, whether they are giving the right kind of instructions or advices, so that people will not make any mistake, or repeated what you call work is avoided, rework is avoided. Then construction project demands heavy reliance on different processes and activities in their interconnection. Therefore, it is necessary to consider the coordination of these processes and activities and their interface to meet the success. Okay, generally what it is saying that your attention, and it demands a lot of input. You have to be reliable on this information what you collected and your solution you have found, and then you give the instruction to the people down the line. And analyze, identification of critical factors and consequent determination of root cause, what we discussed. Construction process is an outdoor activity that is affected by external conditions and repetitive than manufacturing processes, because you are doing a concreting, it is a repetitive kind of thing. Steel fixing or shuttering, this kind of things are repetitive kind of activity. It is one kind of knowledge is required. You don't need to change your knowledge level for each activities. It is practice. Then you come to site access, equipment, logistic, resources, team members, because your site is congested. So you cannot bring materials to the site, and you are logistic, like how many trucks will come, whether all these things are part of the project management or construction management, which affects your quality of the overall project of the system. Because you need to have a general idea about all these things, so that you can achieve a better construction, or maybe project. Then you need to improve. Then project aims to eliminate the identified defects and then upgrading the equipment, purchasing the material of higher quality, because maybe it is the material quality what you receive, it is poor quality, maybe it is not satisfactory, you have to make some kind of a rejection or maybe get the new one, better one. So all this are all part of this Six Sigma processes. It is defined in a sequence. Improving the competency of the staff. Maybe you have what you call staffs are not competent enough to execute the job. Their knowledge level is not enough. Maybe you have to change the people. So that also you have to do. Yeah, then improve. It is necessary to implement an alternative action that provides financial benefits and business development apart from improving the performance at Six Sigma level as high as possible. So sometimes some processes may not be practically possible. You have to think about another alternative action process, which could help. That experience only will help in doing that. Optimization methods lead to project maximize profit. You know that optimization in time, material, people, all these elements what we looked at the beginning, it will contribute to optimize it. You know, your design also is one of the main element. To optimize design will reduce the material cost as well as construction easiness, the type of construction methodology or design methodology you use, so that the construction will not be that complex, so that you can easily do it. So it will improve your profit because it will not have an overrun of the budget. So then control also has so many other this thing like development of the improvement and have been obtained through the implementation of Six Sigma principles. Okay, these are all defining the kind of things to control all these different phases of activities. So then, as I said, it is a continuous improvement in all the thing, and you keep collecting this information continuously. It is not that once you complete your observation, you stop it. Every day, every time when you are doing any activity, even if it is the same thing, you have to keep collecting the data, how it is done, what material, all these things. Whatever is involved in a construction elements, you have to collect the data or inspect or maybe have a proper supervision. So this is also part of the control system. Monitoring improvement process leads to proper evaluation of improvement, ensure that estimated improvement have been attained. So end of the day, what you are done, what all exercise, what you have done in all the phases, that you make sure that your objective is actually attained. Then this will help in previous failures, what your former failures you must always have, that you can avoid by having knowing it. That is why it's very important to have documentation. Then further what we call improvements and the continual perfection. So that is how you achieve a continuous perfection for that. Then conclusion, if you say Six Sigma principle on construction industry theoretically explored, advantages DMAIC. What we have defined, DMAIC is a principal procedure established by Deming in the late 40s and all, so that the activities can be achieved with a proper quality without any defects. Moreover, the flexibility of DMAIC framework in construction projects has been demonstrated and recommended how to implement each phase considering the constructional indices. Because a construction site, we know we make a planning and scheduling at the beginning and a work breakdown structure. We identify each activities and a duration, and then accordingly we make the material list and just in time when you require it, what you require it, all these things you establish. So you can do it in a very organized manner if you follow the Six Sigma principle in mind. So Six Sigma Matrix, that is Six Sigma is actually we are going to see a standard deviation used in statistics as a measure of variation. Actually, how much variation is actually taking place in a process. That is what it is. Six Sigma is basically standard deviation. Six Sigma is the reduction of variation in all our work processes. It's manufacturing, or maybe it is construction, or anything. What we have intended to do it, or maybe decided to do it, and how much we are going beyond the permissible limits. That needs to be studied in detail. So mass products manufacturing, this is more relevant, in fact, but you can apply it in construction as well. People are doing it. So you must have seen this this graph in previous. I have shown normal Six Sigma Matric, how it is a lower specification limit, negative, and positive also upper specification limit. So this is the starting from 3 sigma. The defects per million is 2,700. 4 sigma means 63. 5 sigma means 0.6. And 6 sigma means 99.9999 because it's almost zero. That is what 6 sigma is. But if you have in any operation or anything in 3 sigma or 4 sigma is acceptable, because that is decided by the client and the company. How much is my limit? That is the lower limit and the upper specification limit. So let us see what is actually it is. Example, I'm just trying to explain with an example calculation. A sigma is a variation which is having this equation sigma x minus x dash x bar to the power square divided by n is the number of observation. X is observed values. X dash is the mean of all observed values, that is x1, x2, x3, like that. So we are just seeing we know this is the equation, because this is not the time to explain how the equation has come. I can do that, but I just picked the equation by itself. So we are just going to see an example which is done using this Six Sigma variation calculation, because these are all, this is a restaurant which the temperature of the food is actually measured. So they have made around 10 observations, that is X. Okay. So 10 observation, they found 132 one day, 145, and then it is different temperatures in different times. So when it comes to the second one, and what actually the restaurant or maybe the food industry has actually kept, that I have a lower specification of 130 and a higher specification limit is 135. This is only food, means you can have any kind of procedures, any kind of examples you can put instead of food. Okay, this is one I picked up from the net. So you have established the two limits on the left, lower limit as well as upper limits, 130 and 135. So the X bar is actually, once you have this 10 observations you made and you add all the X values and divide by 10, you will get 133.28. That is the average of the 10 observations. The 132.45, but here you have 133.28. Okay, now you know that 130 lower and 135 higher. So okay, let's see how it is as per the equation. We are the sum x minus x dash x bar to the power. So that is actually the here we are finding the x minus x bar. So the difference is actually in the third column. So that is 0.8 minus 0.3 because it is higher, the x bar is higher. So this is actually the difference between the mean and the observed value. X bar is actually called the mean temperature. Then we come to X, this one, X minus X bar to the square. You square that value, what you get is the value you can get on the fourth column, that this is actually the value you get on X minus X bar, because we can put it in the equation, step 4. And then you see when you put it, sum of the squares, see here it is actually sum of the squares, you will get 2.77 and divide by the number of observations, which is 0.277, and then square root of that, the equation you can see it is 0.53. Okay, this is how we did all the calculations. And then we come back to the observation, and you're putting on the right side the mean value X bar is at the middle, 133.28, and you keep adding each sigma. What is 1 sigma, 2 sigma, 3 sigma? So 0.53 is the average. You keep adding it, and then you will see you will reach to a value which is the upper specification limit is 135. So you reach 134.85. You step 3 sigma. You achieved your limit. Okay. Now in the negative side, you are going up to 130. You have to do up to 6 sigma, because you do the adding of the, minusing this, because it is the left side is negative. So you do the negative thing, minus it, and you will reach 130 at this 1, 2, 3, 4, 5, 6, the 6 sigma. So this is the kind of standard deviation example what you use for finding out your limits, upper limit or lower limits. So you can see that this is 6 sigma. Accordingly, you calculate. You can use any example, like you have to make a number of observation, can be 5 or 10 or 15. It depends on your accuracy level, what do you want. So this is the one example what we come. I hope it is very simple. And if you practice standard deviation, see the, you can go to the net, and there are a lot of what do you call presentations on standard deviation, and examples are being explained in videos. And this is the project charter, Six Sigma, what is actually Lean Six Sigma. So this is business case and problem statement and brief description of the pain being experienced by the organization. The pain being experienced by the organization, that is the problem statement of the company, what you are going to do. Then the goal statement, what do you want to achieve? The goal statement should be specific, measurable, attainable. If you have a specific one, it should be measurable. Otherwise, you cannot manage. Attainable, you don't put certain limit which is not attainable, because you cannot put a level which is practically not possible to achieve. Then time bound, but the duration, whether how long it will take. Then scope statement, whatever scope you have to define correctly and say that this is the scope I am going to do it and going to achieve it. Or maybe this is what the client or maybe the buyer is looking for. Then this maybe I think maybe you have seen this chart. This is actually about lean. What I'm just going to talk about lean now. Any activity which is already, if you want to do any activity and you decided that this activity is going to be implemented. So first you have to check whether this activity is going to add any value to your process or the company, or just an activity. If it is yes, okay, then we will do it. Then if it is not going to add any value, which is only a process which is an additional waste of time, then the question asks, is this necessary? Or analyze the activity. Again, you see that the analysis has to be done whether this activity is useful or adding value, eliminate or modify, we can't, then it's a waste. So if the activity is a useful activity, that is called lean. And if it is not a useful activity decided, then it's a waste, because it's a waste of time. It is not adding any value. All right, then defining value and waste. So how do we define waste on non-value adding process? Because in any operations, because any construction, you can see that so many people do so many things, but all of them are not adding any value to that process, which is making money, because maybe it is not required. So that kind of process is called a waste. Okay, you don't need to do a process which is not adding value to your processes or your construction or your activity or services. So Toyota, this Teichi Ohno defined waste. He's the one who actually defined this lean concept. So what he says, anything other than the minimum amount of equipment, material, parts, and working time absolutely essential to production. All these resources, which the minimum required to achieve your objective, anything excess to that is a waste. So it's a picture what it is actually showing. Whenever if you want to travel from any point A to B, you always choose a straight line or the shortest route. That is called lean. But you look at the top one, A to B, and you are going through this different route for any process making. You are traveling a lot, but it is not giving any added value to that process what you are doing. You need to reach from A to B. So always it is lean. Lean means the most efficient, optimum distance or optimum solution for a problem you have to achieve. That is called basically lean. This is just for understanding this thing. So Lean Six Sigma is Lean Six Sigma means voice of the customer, and Lean and Six Sigma together. Six Sigma, we understood that it is eliminating defects. Now, lean means eliminating waste, time or effort, whatever it is. So this together combined, it is called Lean Six Sigma. So project deployment and customer focused results. All right, this is lean originated at Toyota in 40s after Second World War. Six Sigma originated Motorola in 80s, because Motorola was actually the first company, and they saved billions of dollars by applying or putting Six Sigma into their system. That is what it is. If you read articles about this, they can, it will give the real figures. So this together, so people like Deming and all, then they thought we put together this lean plus Six Sigma. Lean, we know, create value for customers by minimizing waste, and Six Sigma reduces defects by effectively solving problems. So this is equal to Six Sigma. Lean accelerates Six Sigma. Solving problems and improving process is faster and more efficient. So this is how the Lean Six Sigma has been originated. So the Six Sigma was there from 1940, but once the Lean is actually Six Sigma, Lean was there early, but Six Sigma introduced by Motorola, then they combined it. So it is like this. Six Sigma is customer focus, how it is the focus. Six Sigma is always customer for defects, business growth. In the same time, lean means speed and flow. Performance, Six Sigma performance is thinking statistically, because the basis of calculating, as we see, statistics is actually used to find out the variations or maximum 3 sigma or 6 sigma, what is the maximum upper limit or lower limit you can go. Then lean is removing waste, excess inventory, wasted time and motion, constraints, and Six Sigma is systematic development of infrastructure, builds champions, because there is an organizational system in Six Sigma, you can see that white belt, green belt, red belt, and all that. We will see just this thing. What is actually it is. Different levels of development responsibilities are given to the team. The Six Sigma team in any organization with different levels that you need to qualify it actually. So then here lean is reducing complexity and increasing flexibility. So that is how this comparing these two, and both compared together, it will be powerful in concept because together it will work well. So now we come to Six Sigma. Sorry, Lean Six Sigma is actually identified as 8 kinds of waste. The various kinds of waste identified by Lean Six Sigma is defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. Like defect, what we have seen before. Overproduction is production that more than needed or before it is needed. Because you need to produce something what is required at the time of the requirement, not producing and keep it and stacking it, or maybe not falling short of the production. Waiting, wasted time waiting for the next step in a process. Because in one area, you are bar bending and other people are waiting that your shuttering is not finished. So you don't make that activity waiting for you. That is a waste of time. So you have to do a better planning there. Non-utilized talent, many people are actually talented, which is not tapped, or maybe where that we have seen before also. The quality circle, how you people use their talents and then forming small group and then utilizing their knowledge and talents. And transportation is unnecessary movements of products and materials. You unnecessarily waste your time or effort or logistic, by maybe that material is not required at site. You just transport it and you are waiting. There's a lot of wastage of time as well as effort, and maybe it is not required at that particular time. So you need to plan. Inventory, excess products and material not being processed. So your warehouse or maybe your material supplier, and when it is should come. So excess you produce and materials not being processed, and you are getting the material processing that the procurement people are not processed, your material is not coming in time. And motion, unnecessary movements by people. You can see that if you go into a factory or a production site, people walking around, talking and wasting their time as well as others' time. And construction site also, you can see this kind of activities. You should be discouraged and utilize that waste of time. Then extra processing, more work or higher quality than is required, because you don't, suppose you are asked to do an M20 concrete, you don't need to produce an M25, something like that, extra processing. So this is a description of each one. Like the defects and the poor quality control, poor repair, poor documentation, lack of standards, weak or missing processes, misunderstanding of customer needs, poor inventory control, poor design, undocumented design changes. So this is the first one which we see, one of the 8 defects. Waste, which is actually the first one. And then overproduction, just-in-time production, unclear customer needs, producing to a forecast, production planning is not correct, or construction planning is not correct. You are not doing at the time when it is required. You will waste either waiting for it, or maybe it is overdone. The other next department or maybe next people are waiting for it, or maybe they are not able to do it because you didn't finish your work. Long setup times, and each activity you keep a long period more than what is specified. Attempts to avoid long setup times. So the same thing, and poorly applied automation, because many things you are doing not using any tools properly or machines which are easily available, so that can save the overproduction also, because it helps. Automation is one of the most important thing in everywhere, in construction also, because you use most available kind of machines or systems, which is helps to streamline your work. And then now it comes to the next one. Work must be stopped, and the next person in line is overwhelmed because something broke down, because you are waiting for approval. Costs of waiting. This is actually waiting because mathematical mismatched production rates, very long setup times, poor shop layout. Because if you have the site is not organized well, your sequence of work can be affected. Mostly in a manufacturing factory, it is very much important. Your sequence of activity should be considered for making your shop layout. Which activity will come? Suppose you are building a structure, you have to do cutting first, and then tack welding, or fit up next, and then welding, and then painting, like that. So your movement has to be in accordance with the activities, and then the layout also has to be made like. So insufficient staffing, work absences, people are not attending or taking long leaves, who are communicating, people are not talking each other. And then non-utilized, that's another one which I discussed before. People's talents are not tapped. People are employed in particular position, or maybe trade or skills, but they could be used for other ones, because they may be knowing it, but there is no communication that whether this guy can do something better or not. So the knowledge, and this can reduce your waste of time, I can say. Then transportation, poor planned office layout, excessive unnecessary handling, misaligned process flow, poorly designed systems, unnecessary steps in system processes. This is fifth one. Inventory, you have inventory overproduction, production planning is not right, or your site doesn't know what material required at what time, that is just in time production or construction. So you have to see that what time this material is required and how long, how you have to plan it accordingly. Mismatched production speeds, unreliable suppliers, because you order some material from a supplier, they are not turning up or supplying in time. Long set of times, because it's again delays, another thing. Misunderstood customer needs. Many times the working level people should be aware of what is actually the scope, specifications, and they should be briefed most of the time when they are doing a crucial kind of thing. What, like reinforcement is put, what is the spacing of stirrup, or maybe what size of bar. All these things maybe a worker cannot be knowing. Maybe he is not able to read the drawing. So every time when they do the task, you should be updating them, or maybe educating them, or instructing them what to do. So motion, this is another one. We discussed that poor housekeeping, because there is a lot of excessive motion, typical cause of excessive motion. Congestions, isolated operations, lack of standards, you don't know what to do, how good it is. Poor process design and controls. So these are all part of the 7, this thing. Then excess processing is actually this, what I said, you produce more than what is required. Sometimes it is not controlled, it's a waste. Anything which is produced excess is a waste. So that is why it is. Then we come to waste in project management. Defects in correct collection of data. Overproduction means filling unnecessary great amount of documents. Do we need, sometimes people unnecessarily make a lot of documents which is not necessary, maybe repeated, and then waiting for approval from higher management. You want to get to buy a material or something to be done, and your responsibility or your authority is not there to sign off and get things. You have to wait for the management's approvals. So that's a waiting is a waste. Non-utilized talent that we have discussed. Human capabilities to be used as the best for project management. Then transportation, inventory, motion, and excess processing. So engineering design out of waste, designing out waste, because this is one strong or maybe important area where you create a lot of waste, like identifying available standard materials are effectively as possible in order to minimize the amount used for construction. Because what kind of material you will use, when you do a design, selection of material is very important. Why you choose M20 or why you choose M25, who decides that, and what reason you do it. Then the key principles of this thing, identifying opportunity to reduce material use. And a complex type of design will have a lot of waste. So you can do a very simple design so that the principles of engineering is not diluted, but at the same time, the system should work according to what forces and stresses what is coming into it uniformly, or maybe because you don't change the beam sizes because of the span is little less. You will always put the same span because of construction easiness, shuttering and all. You will not wear the bar cannot be put properly. So all these things. Then investigating further opportunity which are easiest, because there is always that is sometimes called value engineering as well. You put your first proposals and you go through it and see that where you can improve and what sort of new technology you can adopt so that you will save material as well as, and your design will reduce your labor resources at site and use material which are easily available for procurement, because you cannot design or put a material which is not available, which you will have a problem for procuring it and you will delay your project. Then offsite concept is efficient procurement. That is what I was just saying. Then conducting value engineering at design stage before construction, because after construction your value engineering will not have much effect, but during the concept stage it is value engineering is more relevant and more valuable, as well as it will give more effect on advantage doing at the basic, because that is the time when you make decisions. Then constructability review, whether you can design so many things, but can be constructed or not. This is another thing which has to go along with the value engineering. Then performance of performance kind of thing, because critical total quality, which is we have CTQ, where options are analyzed diagrams. Following steps leads to Six Sigma project to determine the appropriate critical total quality. That is what it is here. It is input for the CTQ, critical total quality. The DMAIC procedure that we have discussed before, then performance improvement. So comprehensive view of CTQ in construction, because principle, and this is the CTQ actually what are the various CTQs: variation of time, idle equipment, idle labor, material quality, safety measures, functionality, flawless, financial benefits. So all these things are included in the CTQ. And target. So you have to put some kind of a milestone, how much time you require to achieve this. Variation of time, maybe this is just put some time. So accordingly, you can put your target to achieve this CTQs. So definitely you have a planning and scheduling, but sometimes it will go out of the track. and you have to see that it is always maintained so that you will complete the project in time. So you always start looking from the finishing side. When you start a project, you always see the final date and backward. Not if you do it the other way, you will never reach. So these are some graphs which are showing conventional methods, and A is a conventional method. Construction, estimated cost in rides and expiry. A, the red one is conventional, and then you apply Six Sigma. It is actually giving you an advantage of not exceeding your this thing. So if you start applying this technique right from the beginning, you will definitely have an advantage of controlling your expenses, cost, and things like that. So Six Sigma organization structure, this is what I was talking about before. Every organization has an organization structure for Six Sigma. And for that, you have a white belt, yellow belt, green belt, black belt, and the master belt. So what is actually this is how the responsibility changes. White belt is a basis, it is the next one. The master belt is actually a train and coaches black belts. And black belt is leads problem solving of the project. They have a higher level of responsibility and knowledge is required. You have to go through what do you call Six Sigma belt. There are courses, and then you have an exam to pass to get to this kind of levels, organizational levels. So there is responsibility is actually being defined. Green belt assist the data collection and assist the black belt. Yellow belt participate as a project team member. And white belt can work on local problem solving teams that support overall project. That is at the bottom you start with. So you will help the other belts people who are senior in level, and you will be assisting the lower class. So over this thing. So that is how we conclude the Six Sigma and the Lean Six Sigma.